combustion analysis, I would say this is average level of difficulty. All right, let's see. So what you do, let's write out the reaction. You got CXHY. Hydrocarbon means hydrogen and carbon. Oh, let's write this lower. CXHY. You're adding oxygen and you're getting CO2 and water. There's 0.319 grams of this, 0.973 grams, and 0.500 grams. Should I find the grams of oxygen? No, it doesn't matter. You could, but you're wasting your life. Okay? All right. So you're just going to go, you want to find the X and Y. So let's try that. We'll start with the carbon. For carbon, you need the CO2. You're going to convert this to moles. I happen to know the molar mass. It's 44.01 grams per mole. Or you can find it on the periodic table. And then there's 1 mole of carbon for every mole of CO2. Or in other words, there's 1 carbon atom in every CO2 molecule. I did this and I got 0.0, looks like 221, if I'm reading my handwriting correctly. Okay. This is also what on this page? I think somebody said it. X, yeah. When you find moles, the key unit for empirical formulas, which this is moles. So once you get moles, you have the subscript. It might not be your final subscript, but you're getting there. Next, do the same thing for H. Zoom out a little. There we go. H. For H, you gotta start with water. That's H2O. Molar mass of H2O, periodic table, 18.02 grams per mole. Then there's 2 moles of H for every 1 mole H2O. Or there's 2 hydrogens in every water. Okay, so this I got 0.354 moles of H. And this is also Y. Yeah, the variable Y. So I get, do this. When I divided it through CX HY, did I? Yeah, I think that's right. I got, something looks weird. Where's my calculator? Oh, I forgot a 0 here. Ah, there we go. I was like, something's weird. Okay, you just feel it sometimes, like life's not right now. Okay. Now life's better. Some of you feel that all the time. Okay. I got this. It doesn't fit right because I need a whole number here. So I'm just going to multiply by 10.
Just to 16. 10. Yeah, 10.
Wow, that surprised a lot of you. And the answer is D.
Good job.
And get all of it on there. There we go. Okay, I'll give you a moment to think about that and see if you have any questions. While I put it away. Yes? Why did I multiply by 10? Because of law of multiple proportions, I cannot have a fraction in my answer. Every time you have a fraction and you multiply by 10, good. But then you need to factor down. So it was 1 and 1.5 to get 10 and 15, or 2 and 3. You could, if if you want, but you always have to factor down, which I did as well. Is it ever appropriate to round? Rarely. Like if you got a 0.3 on one of them, then I multiply by 3. I'm considering that 1/3. Yeah, and on the exam, I'll try to make it really clear. Like it'll be 0.3 or maybe 0.25 as the fraction. So you multiply by 4. Or it'll be 0.5. Or if it's not one of those numbers, multiply by 10. But even if you did multiply by 10, it doesn't matter. You just factor down to the same answer. Yeah. If you got 1.1, so maybe on the homework you might get something like that, but I'm not usually going to be that cruel on the test. But I would multiply by 10 if I had a 1.1. Yeah, I try to make the numbers pretty clean for the exams. I can't speak for the other instructors. I hope they're the same. Okay, next. Oxidation, hey, we're going to finish, I think. Who asked oxidation states? Did you want like an example? Whoa. Oh, yeah. You want a hard one is what you're saying. Okay? So we're going to do oxidation state. By the way, before we do that, I've got several questions on this, so I want to clarify. This is my reader if you're in another class. Okay, this is on page 22. When you're doing oxidation states, you need to go in order. So these are order of importance. You have to remember the order. So, for example, elemental state, that's just if it's by itself, it's usually 0. But then, the alkaline earth, or fluorine, you've got to remember the charge. Okay? It has to be that. Do that before you get to oxygen or hydrogen. Okay? It has to go in that order. And then do that, and then you can do some algebra from there. Okay. So make sure you go in order. I'm thinking, so don't write too fast. Wait, how hard did you want it? Harder? Harder? A little harder. No. I was going to do really hard, but never mind. I'll do that later, some other day. Yeah, I love it. This is awesome. This, I would say, is hard-ish. All right. I would, when you get something that's kind of complicated, look. Oh, and I want to know the oxidation state of that one, if you weren't sure. Okay. Look for stuff you recognize. I hope you recognize this. It's what? Yeah, it's a hydroxide ion, -1. What's that? Sulfate ion, -2. What's that? 0, just carbon monoxide. And just ammonia. And this? +1. That's potassium. It's in the first column. So, let's see what we got. Now I just said, many of you probably do this in your head, but I'll write it out. Okay? So 2 plus 1 is that one. Plus copper, that's the one we want to know. Plus 2 negative 1s. Plus 1 minus 2. Plus 1, 0. Plus 1, 0. Equals the overall charge. There's no number written here where my pen is, so 0. There's no number right there where that round box is. So it's 0. All right, just a little algebra now. CU, hopefully I set this up correctly. Plus 2 minus 2 minus 2, that sounds like a minus 2 equals 0. Is that an expected charge for copper? Yeah, this is the cupric ion, or copper 2 ion. Cool. Feels good. Okay? See if you have any questions. I have one more topic to ask me about. If you can recognize stuff, it becomes much easier. So we're just putting stuff there for fun, and it's all stuff you can recognize. Okay, moving in. All right.
Last. You better not drink.
Bottom line. I guess I'll drive ice.
Never had it.
Yeah, that's what I was looking for. All right, I want the total number of carbons, hydrogens, and nitrogens, and oxygens. I'll give you a 20-second head start up here. I'll scoot this off, and I'll solve it. I want you to see my answers. Go cheap.
Yeah, I don't know.
Wow, this is a lot. It's better than I thought it was. Okay, I think I got it. Are people ready? Okay. Well, let's do the easy one. There's 2 oxygens, right? Okay, cool. There's 4 nitrogens. How many carbons are there? I got 8. 1, 2, 3, 4, 5, 6, 7, 8. How many hydrogens did you get? How many hydrogens did you get? I got both. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what you have to remember when drawing these, every vertice is a carbon or endpoint is a carbon if no other atom is listed. And every carbon has 4 bonds. If all 4 bonds aren't drawn, then whatever is missing is a hydrogen. So you'll see all the dots are vertice or endpoint. And then I put, a little hard to see here, but purple lines, added purple lines, whether it's a hydrogen, whether it's not 4 bonds to that carbon dot that is shown. This would be a pretty, well, for me, exam question. Cmpds would be not unusual, but you'd also see something like this on the final. It's a pretty classic question as well.